a strike price of 50 at $2.33. So as you know now, it's really just plugging in, the numbers to the equations. Calculating the value on a 5-month European put futures option. Again, I call them options on futures contracts. They call them futures options. So it's basically the same concept. So you have your futures price, you have the exercise price, you have the volatility, and you have the time period. You use the Black-Scholes model to be able to come up with D1 and D2. You put those into basically the valuation model, the strike price, and the futures price. It's a 12% annual risk-free rate for a 5-month period. And then you just put in the numbers and you're going to get the value of the European put futures option of $1.50. What is the delta of a short position in 1,000 euro call options on silver futures? Well, the contract's going to mature in 8 months. The futures contract on the underlying is going to mature in 9 months. The current 9-month futures price is $8 per ounce. The exercise dollar is $8. The risk-free rate is 12%, and the volatility is 18%. So you have your assumptions all laid out. Again, you're using the Black-Scholes model, again, to be able to come up with the 2, the D1, the delta for the option, and then the short position is going to be 0.4886, which is negative because it's going to be short of 488.6 and 1,000 futures options. So you can calculate your delta hedge or your delta short position. The value at risk, you have 2 investments, $100,000 each. You have a daily volatility of 1%. You have a correlation coefficient of 0.3, and you want to calculate what is the 5-day 99% probability of a value at risk for the portfolio. So you know the standard deviation of the daily change is $1,000. The variance of the portfolio, it's going to be 1,000 squared plus 1,000 squared plus 2 times 0.3 times 1,000 and 1,000, which is going to give you 2,600,000. Then you can take the standard deviation of that to get $1,612.45. You can calculate the standard deviation for the portfolio over a 5-day period by taking the standard portfolio daily change multiplied by the square root of 5. Will give you $3,605.55. So that's going to give you the standard deviation of the portfolio over a 5-day period. That's the potential change. Then you can take n minus 1 times 0.01 gives you 2.326. This is 1% of a normal distribution that lies more than 2.326 standard deviation below the mean, so that your 5-day 99% value at risk is the 2.326 times the 3,605.55 gives you a 5-day 99% value at risk of $8,388. Volatility is you can estimate those too. In these examples, so the daily volatility you're going to have with the US dollar to the pound exchange rate of 0.6. The exchange rate was at 4% yesterday at 1.5. You can use the alpha model, EWMA model, which is 0.9. The exchange rate today at 4 was 1.4950. And you want to estimate the daily volatility. So you can take negative 0.055 divided by the 1.5 is going to give you the proportional daily change, which is negative 0.03333. And the current daily variance, which is the 0.06 squared, is going to give you 0.00036. So you can calculate the new daily variance by 0.9 times 0.00036, 0.1 times 0.00333 squared, which is going to give you 0.0003351, which is your new volatility. You take the square root of that, and it's going to give you the new daily volatility of 0.579%. On the credit risk, thank you. You want to calculate the spread on a 3-year corporate bond, and yield on a similar risk-free bond is 50 basis points. So the spread between the corporate and the similar risk-free is you have a spread of 50 basis points. The recovery rate is 30%, and you want to estimate the average hazard rate per year for the next 3 years. So you take that 50 basis points divided by 1 minus the 0.3, which is the recovery rate, is going to give you 0.71% per year. So that's going to be your estimated hazard rate per year of the 3-year period. And problem 24.2, the spread is now 60 basis points. The recovery rate is still 30%. Your average hazard rate in year 4 and 5 is what you're trying to figure out. So the average hazard rate over 5 years equals the 0.0060, which is the basis point spread. 1 minus the recovery rate is going to give you 0.086. And that's going to be the average hazard rate is going to be 0.86% per year. Then the hazard rate from up here is 0.71% per year for the first 3 years. So to be able to calculate the hazard rate for year 4 and 5, you take the 0.0086 times 5 minus 0.0071 times 3 divided by 2 is going to give you a average hazard rate for years 4 and 5. In problem 24.1, you have the LIBOR, you have a LIBOR swap curve. The LIBOR is flat at 6. You have continuous compounding. You have a 5-year bond with a coupon of 5%. It paid semi-annually and currently sells for $90. How would an asset swap on the bond be structured? Is what you're trying to do. So the first is, what is the asset swap spread? Well, the principal is $100. The asset swap is structured so that $10 is paid initially, and after that, $2.50 is paid every 6 months. In return, you're going to get LIBOR plus some spread, which is going to be received on the $100 principal that you used for the swap contract. So to get the present value of the fixed payments, you're going to take the $10 plus the $2.50 e to the negative 0.06 to the 0.5. Then you're going to add that 2.5 to the e minus 0.06 to the 1, and then you're going to replicate those payments out and take the principal amount at the end to calculate the present value of the principal payments. So you come up with the present value of the principal payments first. Then you look at the spread over the LIBOR, and you calculate the present value for that, which is, in this case, 5.3579 So the present value of a dollar received every 6 months for 5 years comes out to be $8.51.05. So the spread received every 6 months is going to be the spread over the LIBOR, the present value, divided by the present value of the $1 received every 6 months for 5 years. That's going to give you 0.62 or 0.6296. And then your asset swap is going to be 2 times this, so your annual asset swap is going to be 1.2592%. And then the last is another value at risk calculation. You have a bank that has $10 million exposure. Within 1 year, there's a 1% probability of default. The recovery rate is 40%. Your correlation parameter is 0.2. You're estimating a 99.5% 1 year credit value at risk as a worst case scenario. So what is the worst case scenario that the $10 million exposure could impact the bank? So you would put the variables into the equation, and you're going to get 0.0946. And then you take the 10 times 1 minus 0.4 times 0.0946 to be able to calculate the exposure. And in this case, it is $568,000 of the $10 million is the value at risk that the bank would be exposed to in a worst case default scenario. So those are just some of the problems that I pulled out that I know you've been working on, but I think as you start to work through them more, they become more intuitive.